Hello, everyone. I'm Jingwen Huang, a analytics EIT at Transalta. I'm excited to work with Subu on this project. Pass it to you.
Thank you, Jingwen. Hi, everybody. I'm Subu. I'm an analytics EIT at Transalta. I'm working in the performance engineering team. We are excited to show you Nav Assistant. All right, let's go for a spin. So we would like to give you a project background. Our project is mainly based off of the manufacturing and energy industry. And the key problem of the energy industry is that our technicians and engineers face a lot of delays in diagnosing problems. And the major reason is because when a problem arises, we would have to go through OEM documentation, SCADA data, as well as other information. And we would have to collect them, analyze them, and then provide resolution based off of this. So our goal is to improve the productivity of the field service agents and the engineers, and also increase the value of the organization by enabling a productive workforce. Moving on, our ideas key target areas include these two areas. First one is creating an accurate asset information assistant. So no more waiting for data requests or access requests to different information, and you can do your diligence for your critical work. Second is breaking data silos. So Nav Assistant would be focused more on accessing different data sources from different areas. So this way we wouldn't have to wait for the access request to be accepted. Lastly, it's an orientation buddy as well, where we can incorporate the existing orientation training program with the Nav Assistant so that new employees can get latest and up-to-date information. This is our Nav Assistant. This is a mock-up of our application. Now, let's go through a demo case at a solar site, which is a fictional solar site, and let's go through the real problems that the solar site is facing and how Nav Assistant can be of help. All right, this is an automated email from the Solar Ops Pro team. This gives us a quick summary of what issues has been happening in the solar sites. Now let's take a quick look at the summary of the solar SCADA report that gives us an idea of which sites have been impacted the largest with the fault codes that has been happening for the most amount of time. So this is the SCADA data. Now let's go into the operation and maintenance report, and this is a bunch of weekly reports that come in from the site regarding the issues that have been happening on site. Now, given this information, as a solar performance engineer, I would have to go through additional documentation as OEM manuals to understand what's the best resolution for mitigating these issues. Now, let's take a look at how all of this could be made easier using the Nav Assistant. Here, this is the chatbot where I ask the Nav Assistant what is the issue with the New Jersey solar site, and then it gives me an idea of what's the financial impact as well as what's the base issue for that revenue loss. It also gives me ideas on how I can mitigate these issues. It does not give me the fault code because it interprets the fault code, goes into the OEM manual, as well as understands the context of the OEM manual to give me these mitigation issues. And also, at the end, it gives me 3 action items to execute in the New Jersey solar site. This way, I can reduce my time to access all these documents, as well as reduce my time to read through a bunch of documents to find the actual information I'm looking for. And in case if I want to verify this information, I can just simply click on the document and then go through the information myself, as well as understand how these information is generated.
For value proposition, our Nav Assistant streamlines document interpretation, resolving industry issues faster. By automating the tedious task of searching through vast amounts of documents for answers, we save valuable time and resources. According to Forbes, knowledge workers spend approximately 19% of their time annually searching for information, while data professionals allocate around 50% of their time to this task. With our solution, business can overcome delays, boost efficiency, and stay agile in fast-paced environment, enabling employees to dedicate more focus to critical tasks like analysis and innovation. Let's take a look at our process map. End user asks a question. How this works internally is that the question will be embedded in vector format. A similarity search will be performed to retrieve the most relevant data chunks from vector database. The response will then be generated from this data chunks with predefined prompt template to the end user. Let's take a look at our current state. We set up a RAG pipeline that's tailored for our specific task. We've finely tuned the model to ensure it delivers high-quality responses. Additionally, we've developed a user-friendly interface to facilitate seamless interaction for Q&A. To ensure consistent high-quality responses from the Nav Assistant, we undergo iterative refinement of the model, evaluating it against key metrics. Leveraging Databricks experiment UI, we compare models with varying chunk sizes and key values to gauge their performance. We access correctness by comparing responses against verified datasets, aiming for higher score. Relevance is evaluated based on how well responses address user queries, aiming for higher score. Readability is accessed using the automated readability index ARI score. You can see in this image different reading levels and its corresponding scores. We're aiming for scores between 12 to 19 for easy comprehension. Faithfulness is determined by aligning answers with knowledge base. Professionalism and toxicity are ensured by evaluating language appropriateness and respectfulness. The lower the toxicity, the better. Based on these metrics, we set chunk size to 300 and key value to 4 to achieve optimal scores. This comprehensive evaluation guides our model selection for deployment, enhancing the chatbot's performance and user satisfaction.
Our primary future goal for Nav Assistant is implementing an annual audit system to ensure model integrity. Subject matter experts from various sectors will review the RAG pipeline's output during iterative improvements. The audit system also aims to gather SME feedback and current data to enhance the robustness of our RAG pipeline. Moving on to our goals for performance improvements and scaling, we aim to develop a mobile app for the assistant for quick system access. We intend to integrate and assess different re-ranking systems for the retrieval chain, like cohere ranking, which prioritizes context relevance and improves vector search outcomes. To mitigate potential prompt attacks, we will deploy models like LlamaGuard. Moreover, leveraging our reproducible code base, we will expand into additional energy types like wind, hydro, and thermal. We also plan on collaborating with cloud service partners to enhance our model experimentation and inference efficiency. As we scale to different energy types, we rack up huge amounts of data with small data sets for evaluation. We plan to address this issue by creating an evaluation data generation pipeline using Instruct LLMs that generates context-based questions and answers. Generating evaluation data on proprietary documents using RackChain would be highly cost efficient when compared to human evaluations, and it would be more relevant than public evaluation datasets. So far, we have seen the existing process for the site issues diagnosis. Now, let's take a look at Nav Assistant, how it improves from existing solutions. The annual audit system will help us to create a robust RAG pipeline. The initial effort to develop the RAG pipeline can be easily scaled for other energy types through code replication, and this can be seamlessly done using the Databricks platform. Since we can also connect to various data sources through Databricks, we can overcome the data silo challenges. Lastly, I will touch on our tech stack used for the project. We have utilized industry-leading cloud partners like AWS and Databricks for our project. We have also leveraged the Databricks platform to build an end-to-end RAG pipeline. Our primary large language model for the RAG pipeline is the Mistral 7 billion model, and we have used the DBRX Instruct model for evaluation. And that concludes our presentation. Thank you for your time, and please let us know if you have any questions.